Hello, my young physicists, and welcome. So let's see here. I'm going to be assisting you with the horizontal projectile motion assignment, and specifically we're going to be looking at problem number 5 here. I remember quite a few students had some struggles with this one. The diagram's pretty easy, but the equation selection is the difficult part for it, okay? So let's see if I can't help you out with this. So here's what we're looking at. We have our basketball player, right? A certain height. And he's going to be throwing his basketball a certain distance from his height, okay? And it's going to be a horizontal throw, and we're going to be having something like that going on, okay, with this parabolic trajectory that we're dealing with here. So they gave us the height of the player, which will be our delta y, our displacement vertically, and that it gave us was 2.45 meters. But we're going to go ahead and call this amount negative, since remember it's measuring from up here where the ball is to down here. We're going to put as negative 2.45 meters. Now they didn't give us the delta x, which means it didn't give us our displacement horizontally here. They gave us our final speed right before the basketball hit the ground, which was 12.0 meters per second. And what we're needing to solve for is what was the initial speed of our basketball thrown by our basketball player here, okay? That's all they gave us in the problem. Some things that we know, like we're used to using, is that our acceleration in the y is equal to negative 9.8 meters per second squared, okay? Now, in this problem, I gave you a hint, and I told you to remember that for your components of speed, you can say that your velocity, final, you break it down into the x and y components. You have your x component of speed here and your y component of speed, okay? And I gave you this equation. I said, remember, for the Pythagorean theorem, where this would be c, this would be a, and this would be b, you can say a squared plus b squared equals c squared, right? Which you can substitute that as vy squared plus vx squared equals your overall speed final squared, okay? So what we need to do is we need to ultimately try to solve for our x, okay? Because remember that your x, not just squared, but your x component of your speed is equal to the initial speed, because your initial speed remains constant throughout this whole problem. Throughout any horizontal projectile motion, the initial speed and the x is equal to the final speed. The speed stays constant, doesn't change. So you could also say that this is our initial speed as well. You could substitute that guy in. So what we need to do is, since we're going to be solving for this, and we already know this, we need to see, because we can only solve for one variable at a time when you're using one equation, we need to look for another equation that's going to help us solve for our y component of speed. And if you look back at the kinematics equations that we've used before, back in chapter 2, you'll notice that there's this equation available to you. This equation of final speed squared equals your initial speed squared plus 2a delta x. Now remember, since we're trying to solve for the y component here, we're going to take this kinematic equation from chapter 2 and change our variables to be reflecting for the y component of our speed. So for final speed, that's our final speed in the y component, so I'm putting sub y squared, equals our initial speed in the y component squared plus 2 acceleration in the y component and delta x. Well, now we're looking at delta y because that's the y component, all right? Now, before we go any further with this equation, remember, just like with all of our other horizontal projectile motion problems, the speed initially in the y, that's the vertical component, is 0. There is no initial speed in the y component. So that means this guy is going to be 0. It's gone. So when you rewrite the equation, you have that your speed final in the y squared equals 2ay delta y. Okay, so now check out what we're dealing with here. We can solve for this component, which we will be substituting in over here. I know it doesn't show a little final, but you could put a subfinal if you wanted as well. And we also know that our acceleration in the y, we've got that negative 9.81 meters per second, and our delta y, that was our height of our player, is also available to us too. So once you've solved for this, after you've done the unit analysis step, you'll be ready to ultimately plug it in over here. So I trust that you'll be able to do the unit analysis as well. And don't forget with before you can do the unit analysis, you'll have to do the algebraic manipulation, which to isolate this variable squared here, you're going to have to take the square root by both sides. And when you do that, these guys cancel out, and so you get your final speed in the y component is equal to the square root of 2ay delta y. All right, and I'll show you the unit analysis step here real quick to help you out. Now for our speed is going to be in, since these are already the units that we're dealing with for speed meters per second, that's a good idea to choose those units as well over here that we're going to be solving for. So square root, 2 doesn't have units on it, so not worried about it. Acceleration in the y component, well, we have those units of meters per second squared, and again I'm going to be stacking my fraction units, okay? Meters per second squared times our delta y units are in meters. So I'll put meters over 1 here to kind of get it in line. Now, nothing's canceling out right here, so we're going to have to combine our terms. So we still have meters per second over here is equal to the square root of meters squared over seconds squared. You see how we just combined those together. So the squares are canceling out because of the square root, so when you rewrite it, it becomes meters over seconds equals meters over seconds, okay? And so we're good to go unit analysis. Then, like I said, you would just do the substitution step, and you would be ultimately plugging that in for this guy right here, but we need to solve for our final velocity, correct? Right? Excuse me, no, we have our final velocity. We need to solve for our speed component in the x, because that remains constant throughout this whole trip. So to isolate our speed component in the x, we'll say delta x squared, and then plus our, not delta, excuse me, our speed in the x squared, speed in the y squared, and I'm just kind of rewriting it over here so we have a little bit more room to work with, equals our speed final squared. So to isolate this variable, we're going to have to subtract our y component, y squared. So that cancels out over here. So our x speed in the x squared equals our speed final, that's all together squared, minus our speed in the y component squared. All right? And so since this is squared, to isolate this variable, we have to square root it. So the square and the root cancel out. So you have speed in the x equal square root of your final velocity squared minus your y component squared, which our final velocity, they gave us that in this problem. Our y component of our speed or velocity is being solved, or will be solved. You can do that one right here with this equation, okay? So you should be good to go once you have that, all right? So if you need more help than that, please come see me, and I'd love to work with you one-on-one.